Welcome back to a new episode of Scientific Smart Question. We are now discussing the different chapters of class 10 Icse. But before that, I have a small request to all of our students that please subscribe well as as distribute the videos and share the videos to your friends so that they can also take the advantage of this video. I am now discussing on class 10 ICSE periodic properties. Let's start today's topic. So, how is ionization ionic radius? Ionic radius. Actually, how is ionic radius affected or generalized in this periodic table? You have to remember that cation, as for example Na plus, etc., cation have smaller size, whereas size of energy is larger to the parental. Why? There is a question arises. Because in cation, the same, the rather, there is less number of electrons than the parent atom. So this less number of electrons is easily attracted by the so-called nucleus, and that's why here cation is has a smaller size. Now you have to remember ionization enthalpy. Ionization enthalpy. It is the amount of energy required to remove the most loosely bound electrons. So it is actually an energy, amount of energy required, amount of energy required to remove the most loosely bound electron, to remove the most loosely bound electron. Loosely bound electron from the isolated gaseous atom in the ground state. From the isolated gaseous ion in the ground state. So it is ionization enthalpy. As for example, Ag, this is a gas. Here the electron released and it formed A plus G plus electron. Here enthalpy equal to delta H equal to delta 1H1. Then the next one, Ag, A gaseous, again a electron plus E. Here delta H equal to delta 1H2. It is for a unipositive ion. Now, this enthalpy, that is the ionization enthalpy, increases in atomic size. Ionization enthalpy decreases. Actually, this ionization enthalpy decreases with increasing atomic size, with increase in atomic size. they increases with increase in nuclear charge. They decreases with increase in penetration power. Power of electrons. Atom having a more stable configuration has high value of enthalpy. So more stable configuration, more stable configuration means very high enthalpy. Variation across a period. In a period, what is the variation? What is the trend of variation? Increases with increase in atomic number. So increases with increase atomic number. Variation in group decreases with increase in atomic number. With increase in atomic number. So this is the enthalpy and electron gain enthalpy, gaining of electron enthalpy. So this is the part of enthalpy, the trend of enthalpy in the periodic periodic table, ionization enthalpy. Next, the term we should know, that is electronegativity. Electronegativity. It is a very important term. You have to know it. Electronegativity. It is defined as the tendency of atom in molecule. So it is the tendency of atom in a molecule. Atom in a molecule. Molecule. Tendency of atom in a molecule to attract the shared pair of electrons. To attract the shared pair of electrons. To attract the shared pair of electron towards itself. Greater the effective nuclear charge, greater the electron. So greater the effective nuclear charge, greater is the electronegativity. If the number of valence electron less than 4, valence equal to number of the valence electrons. If the number of valence electron greater than 4, valence equal to 8 minus. So there is a formula. You have to know, that is the electronegativity. Greater the effective nuclear charge, greater is the electronegativity. And vice versa, that is the smaller the atomic radius, greater is the electron. So smaller the atomic radius, greater is the electronegativity. Greater the electronegativity. in a period in a period in a period increases on moving from left to right. So from left to right, electronegativity increases. In a group, in a group, decreases in moving down the group. So if we in a group, if we move down, it will decreases. So this is the trend of electronegativity. You have to memorize, or rather you understand this trend of electronegativity in the periodic table. So no more for today. Let's stop our study, and once again thanks for being with us.